Walaikum Salam.
Weak acids, weak bases, and how do you classify them, on what basis we are having classification. On that discussion which we have made in the previous two classes, that is called qualitative treatment for ionic equilibrium. Right now, the second phase of this discussion is, let us go for quantitative approach. How you are going to say, sir, we are saying weak acids, no problem. In the previous class, I have said one concept that all strong acids are equally strong in presence of water. That is known as leveling effect of water. All strong bases are equally strong in presence of water. That is also called as leveling effect of water. I said that the concept of leveling effect of water has no significance, no meaning in case of weak electrolytes. Wherever we are having the word strong electrolytes, the word leveling effect is meaningful. Otherwise, that effect is not useful. Once you understand that, then we can say, okay, sir, I'm having a group of weak acids, right? If suppose it is so, then can I compare those weak acids? Yes, that is the way with which we try to have quantitative treatment, right? We want to have comparative account with respect to all those substances which are declared as weak electrolytes. So in case of weak electrolytes, how do you have comparison with respect to their strength? For this purpose, today we'll start qualitative treatment. All right, come on, how to proceed? Mohammed Rabah, please check your system. It's your problem, not my problem. Everyone is listening properly. Please check up your system. Wait a minute. First, let me mute all of you. That is I. Usually further, otherwise unnecessary shouting. Yes. Is it visible to audible to everybody? Audibility is clear, then fine. Those who are having problem, please check up your system, right? Okay, go ahead. Next. Now, suppose for example, you are discussing about quantitative treatment. For this purpose, see how to proceed. This today's discussion. Now I am entering into main chapter. Today we are going into main chapter, right? Let us see how to proceed for that. Consider a weak electrolyte. Weak electrolyte. Who is that fellow? Let us take general discussion. AB, something, right? No, sir. Let us go for a specific thing that is called acid, weak acid or weak base. Consider a weak acid. Say, for example, WA, right? Who is that fellow? HA. Why you are saying HA? Sir, I am following what we can say Arrhenius theory of acids and bases, which says that we are having what we can say releasing tendency of H plus ion, and Bronsted theory, we are having tendency to go with respect to Bronsted theory. Therefore, when we are discussing this for weak electrolytes, please write down full form of this weak electrolyte. I don't have any problem with the voice. Everything is correct. If you are able to listen me, please listen. Otherwise, I'll close up the class. I'm not interested at all. If anybody, any one member is having problem, please check up. Please check up. Please check up. If you understand English, please check up. Very low, very low, very low. अगर आप 10 बार भी पुकारेंगे तो यहाँ पर कुछ फर्क नहीं होगा बेटा. I know it's clear. I asked just now. Most of them said yes, sir. This, yes, sir. Everyone is having problem. Any one fellow, he has to check up instead of writing 4 to 5 times very low star, very low. अकल क्या घास चरने गए थे क्या अकल देते वक्त? इतना सिस्टमैटिक वे से स्पिरिट से मैं इंटर होता हूं क्लास में, इतने बदतमीज लोग हैं. చెప్పండి సార్. సీనియర్ నెట్వర్క్ కి ఒక్క నిమిషం వీళ్ళు మ్యూట్ చేసేస్తాను. If you are in the college, ask the college person to check the system. Shall I start? Should I stop? Is it clear now? Audibility is clear. when we want to understand the quantitative approach with respect to electrolytes, then let us consider this one. I have taken acid, say for example HA, right? Now this acid is to be added into water. Then what happens? Since it is a weak electrolyte, there is a reversibility and there is a formation of a hydronium ion, because Ha is donor of proton, and there is a formation of A minus. As you take example of acetic acid, CH3COOH plus water gives you hydronium ion plus acetate ion. Let us take general example like this. But this is the correct way of representation. But what happens, for simplicity, we write that HA. This is not correct method. This is not correct method. This is for understanding. What we people write generally, it gives you H plus and A minus. This is for understanding what is happening. Simply we are having removal of proton, Arrhenius theory, right, or Bronsted theory, whatever you apply. But the correct way of writing is this one. Keep both of this in mind. Come on, at time t is equal to 0. What is our method in chemical equilibrium? 1, 0, 0. Objection, sir. What about water? We have written nothing in case of water. Remember carefully and clearly. In this chapter, from today onwards till the end of the chapter, water is our closest friend. Water is available in every class of ionic equilibrium, and he is sitting at the last bench of the classroom. But we do not involve water in the process of discussion because we say water is a medium, water is a solvent, right? This is one way of saying the answer, but I'll change my answer in the next class, or if possible today itself. At present, I am saying for your understanding level, rhythm number 1, that this is taken as medium, this is taken as solvent. Nice. Now, or let us take, if you are genius person, students, you people are genius, therefore let's go to second aspect. What is second aspect? Sir, water is pure liquid, therefore active mass of water is taken as 1. Therefore we do not count here in this case because of its solvent nature, or it is behaving as medium. Okay, time t is equal to t. When you attain the equilibrium, when you are having a reaching point of equilibrium, what was our method? 1 minus alpha, alpha and alpha. And what is alpha? Degree of dissociation. But remember, in chemical equilibrium, 1, 0, 0, A 0, 0, X 0, something we have written like this. But remember, in chemical equilibrium, we say like this, that this is taken in the form of C, right? Actually, C into 1. Let me say like that, that this is supposed to be C into 1. If it is so, this is C into 1 minus alpha. This is C alpha. This is C alpha. Now learn this method. In whole of this chemical ionic equilibrium chapter, we always try to say that the concentration available at time t is equal to equilibrium is not in terms of 1 or in terms of A or X. We say C0, 0, C into 1 minus alpha, C alpha and C alpha. Okay, okay. Once we have this one, then go to equilibrium constant. What is that? K. Objections are, what is this K? Is it Kc or Kp? Remember, it is equilibrium constant. And in all ionic equilibrium chapter, every discussion is solution phase discussion. Either we take molten system or aqueous solution. No, we don't take molten also in this chapter. Either it is possible to understand ionization if you take molten state or aqueous solution, but in this chapter we'll take only aqueous solution. Therefore, there is no question of Kp in this chapter. There is no question of discussion of effect of pressure in this chapter. Pressure and Kp both are absent in whole of these classes known as ionic equilibrium. Then what is this? This is Kc, but we not write Kc because we are entering into new chapter and new idea. We'll try to give a new name to that one. What is that name? What is the process going on? Ionization. Of what? Acid. Therefore, it is called acid ionization constant. It is known as acid ionization constant. Therefore, it is written as Ka. Acid ionization constant Ka. Come on, go ahead. Base ionization constant Kb. Right? We are discussing about weak electrolytes under the heading of acids and bases. Therefore, that equilibrium constant is nothing but equilibrium constant known as Ka or Kb. Come on, Ka. What is that? Nothing, sir. Concentration of hydronium ion. We can write like this. No, I want to go in precise manner. If you want to go in precise manner, then what I had to say? No, sir, this is supposed to be concentration like this, that we are having concentration of hydronium ion. Remember, you are writing concentration of hydronium ion, but in your mind, it should be H plus. It is H plus. Concentration of acetate ion like that, anion, right? Divided by concentration of Ha. And now we should say why we have not taken water. Sir, water is a pure liquid. Active mass of water is taken. In chemical equilibrium, we have learned that active mass of water is taken as 1. This is medium, this is solvent, this is pure liquid. Therefore, we take it as 1. Hence, it is not considered. What is this? Concentration of ionized form of H plus, concentration of ionized form of anion, concentration of undissociated molecule, unionized form of substance. Therefore, if you want to write ionization constant Ka, this is equal to C alpha, concentration of H plus ion. You people are genius. Therefore, okay, C square alpha square, concentration of H plus ion into concentration of A minus by concentration of unionized, undissociated form of weak acid, C into 1 minus alpha. Therefore, if you consider this, then you get one statement known as Ka. Acid ionization constant is equal to C alpha square by 1 minus alpha. This is the expression, right, which is used to understand quantitative nature of weak electrolytes, for example, acid. Similarly, if I say Kb, C alpha square by 1 minus alpha, where alpha is known as degree of dissociation of weak base and Kb is known as base ionization constant. Remember this. IIT mains students, remember this. Acid plus water, acid ionization constant. Base plus water, base ionization constant, right? Something XYZ in water, XYZ ionization constant. That is the method of doing problems in application type. Come on. Once you are saying this one, then the question comes, sir, what about concentration of H plus ion? Concentration of H plus ion at equilibrium is very simple, C alpha. What about concentration of anionic form of electrolyte? C alpha. What is concentration of unionized form of acid? C into 1 minus alpha. Fine. Once you understand all these things, then the question comes here, sir. If suppose, for example, you are saying alpha, what is alpha? Degree of dissociation. And degree of dissociation of what? Degree of dissociation of weak electrolytes. Now the question is, if suppose, for example, you are saying that there are weak electrolytes, it implies you are having relatively weaker, relatively stronger. That means in case of strong acids and strong bases, we said leveling effect of water. Here we don't have leveling effect. Therefore, if you have group of weak acids, you should say this is much weaker, this is much stronger. Comparison we can do, and that all depends upon degree of dissociation. Therefore, suppose, for example, if degree of dissociation of any weak acid or weak base is more than 5%. What is the meaning of more than 5%? If alpha numerical value is 0.05, then in that case, remember Ka is written and calculated in the form of C alpha square by 1 minus alpha. However, remember, this is accuracy. This is accurate expression. Remember, in mains examination and in NEET examination, they will not create problems in this form because they don't want to check their mathematical skills. They want to check their depth in physical chemistry. For that purpose, if suppose, for example, you are saying weak electrolyte whose degree of dissociation is less than 5%. Here what I am making new correction, alpha is equal to or more than. Suppose for example, if alpha is given as equal to or more than 5%. Say for example, if I am writing, sir, alpha is given in the form of more than or equal to 5%, more than or equal to 0.05. Go by this expression. But suppose if it is less than 5%, what is the meaning of that? Less than 0.05. If this is the numerical value, say for example 10%, 1%, 2%, 0.1%, if it is so, then we can say it is less than 5%. If it is so, people say 1 minus alpha is almost equal to 1. What is the reason? Reason is this stage, at this stage, we people say alpha is dash. And if it is negligible, come on, what is to be done? Ka is equal to, how to neglect it? Sir, the word neglection comes when there is a comparison. Numerator, we don't have comparison. In denominator, I am comparing alpha with 1. Therefore, this C alpha square remains as it is. This 1 minus alpha becomes as 1. That means whenever you are saying that we are having very weak electrolytes, and if suppose for example you are saying that alpha is negligible, then Ka is given as C alpha square. This is the expression known as approximate calculation. Be careful here. If you are solving the problems, always Ka is equal to C alpha square applicable to give correct answer if alpha is less than 5% or its numerical value is less than 0.05. And we have 99% examples and problems in examination in this aspect only. If it is so, then you have something ax square plus bx plus c is equal to 0 type of equation. You have to go for quadratic equation and alpha beta roots. All that is not necessary for a physical chemistry student to show its caliber. Therefore, we say K is equal to C alpha square. But remember, it is approximation. Okay. Once you understand, then you can have, sir, if suppose, for example, you are saying so, let us try to enjoy the concept of degree of dissociation, because quantitative comparative account is given only because of degree of dissociation. If degree of dissociation is more, the substance is supposed to be a stronger substance. If degree of dissociation is less, the substance is weaker. So ultimately, the tool is degree of dissociation, and that tool is given as under root K by C. If you are talking about this, then we can have different type of comparisons. For example, you can say, sir, if it is taken alpha is equal to, why alpha is equal to alpha 1 by alpha 2, let us take like this. That is a comparative story. If suppose, for example, if you have taken alpha 1 by alpha 2 is equal to under root Ka1 Ka2 into dash C2 by C1, inversely proportional to concentration. No, sir. Here, suppose for example, acid is same. For same acid, I want to compare the strength. Is it possible? Yes. Concentration, strength of substance depends upon concentration also, along with the Ka. What is Ka? Equilibrium constant. Therefore, K depends upon nature, temperature. Go back to chemical equilibrium. I said nature and temperature. You are saying, sir, I want to keep nature as the same. Acetic acid I want to study. Now I want to say 0.1 molar, 0.01 molar, 0.001 molar. Sir, I want to enjoy comparison with respect to strength. Alpha 1, alpha 2 can be compared like this. Therefore, for a given acid, what is the meaning of for a given acid? Ka is constant. And once you are saying K is constant, alpha is directly proportional, inversely proportional to given concentration. No, sir. Concentration and volume are directly proportional. Therefore, yes, it is directly proportional to volume. Degree of dissociation is directly proportional to, degree of dissociation of weak electrolyte is directly proportional to dilution. That means as dilution increases, degree of dissociation of weak electrolyte also increases. Go on adding water, right? Earlier, it was 10% ionized. If you add further amount of water, 20%, 40%, 50%, 60%. Sir, what is the problem? The problem is, yes, if suppose, for example, you goes on adding water, there will be a stage where all the molecular substances undergo complete ionization, right? That means higher the degree of dilution, more is the extent of dissociation. Therefore, people say alpha 1 by alpha 2 is equal to under root V1 by V2. Sir, volume has increased. Dilution has been done in such a way that volume is increased 4 times. What happens to degree of dissociation? Degree of dissociation becomes doubled. That means degree of dissociation of weak electrolytes depends upon, of course, nature. At the same time, it depends upon volume, dilution of the solution. And because of this reason, we honor this person and we say that this is known as Ostwald's dilution law. In case of weak electrolytes, as dilution increases, degree of dissociation also increases. That is known as Ostwald dilution law. Come on, go ahead. IIT main students, this is very, very important for solving problems. Remember, whenever alpha is given to you, listen carefully. Whenever alpha is given to you, it's very simple to apply all the concept because you people are genius. But suppose, for example, alpha is not given to you, please check. First, you have to find out the alpha value. If alpha value is more than 5%, go by accurate expression, C alpha square by 1 minus alpha. If alpha is less than 5%, then go for approximation. That is necessary for IIT mains students. For NEET students, no problem because they will not give you mathematical treatment oriented problems. Therefore, usually they will create problems where alpha is negligible. For IIT mains, but listen, again, I am saying if alpha is not given to you in the problem and you want to go to calculate and proceed through alpha, never use directly Ka is equal to C alpha square. First of all, check up the value of K alpha. How can you check up the value of K alpha? Under root K by C. If the value of alpha is, say, for example, 20%, 40%, then go systematically C alpha square by 1 minus alpha. If alpha is found to be less than 5%, then go for approximation. Is it over? Go ahead, write down, no problem. Write down. Done. Very good. Now, once you understand degree of dissociation, keep the target in your mind. Our target is to have quantitative discussion of weak electrolytes, maybe acid, maybe base, right? The same thing you can repeat in case of basic substances also. OH minus ion is equal to C alpha, B plus, there will be cation C alpha, and BOH. Suppose, for example, if you're following the Arrhenius theory, C into 1 minus alpha. Right, you can do the same thing, and here the word becomes Kb. Kb is equal to C alpha square and all those things. Now, once you are having this one, then C, H plus ion concentration is C alpha. Let us go to the next discussion. H plus ion concentration is equal to concentration of H plus ion is equal to C alpha. Remember, this is accurate. It is not approximation. I have not done anything here. Simply accurate. No, sir, I want to substitute the value of alpha, right? If alpha is very much less than 1. This is another way of saying negligible, less than 0.05, less than 5%. This is something like this. Then what happens? Then H plus ion concentration is equal to C alpha. What is alpha? Alpha is under root K by C. And if you simplify, you people are genius mathematicians. Alpha H plus ion concentration is equal to under root Ka into C. Yes, this is the method with which we try to calculate the H plus ion concentration and this is approximation because we have used the term under root K by C. Okay. Now, once you're having this one, then H plus ion concentration depends upon two parameters. It depends upon what is the concentration of the acid or base you have chosen and what is the constant, acid ionization constant, base ionization constant. Right. Once you are discussing this, then the question comes, sir, we are talking about alpha. Before going to have further discussion, quantitative discussion means let us talk about alpha. Who is this fellow? Alpha is degree of ionization. Go back to previous chapter, chemical equilibrium. I used to say degree of dissociation. Yes, it's correct. But here, the same thing, dissociation, we call it in a smart way known as degree of dissociation is in the name of degree of ionization. If you are saying dissociation, no problem, nothing harmful there. -1 is not given to you. You will be successful. Now the question is, what is alpha? Point number one. Point number two, what are the factors which affects alpha? Okay, let us enjoy that now. Suppose, for example, if we are saying what is alpha, sir, we know it already. We have done in the previous classes that suppose, for example, if we are saying alpha, it is called degree of dissociation. It is something out of 1. Alpha is something out of 1. Okay. Now, sir, not like that. If you want to write in mathematical way, Arrhenius has given one expression. What is that? Degree of dissociation means how many were given to you, how many are dissociated. That means number of moles of weak acid or weak base. Number of moles of weak acid or weak base ionized divided by number of moles of weak acid or weak base at time t is equal to 0. I have given 100 moles of acetic acid. I am having 60 H plus ion, 60 acetate ion, and 40 acetic acid molecules are still undissociated. 60% dissociation, right? How much has been ionized? How much has been taken? This is called degree of dissociation. Okay, nice. Next, what is degree of dissociation? Finished. What are the factors upon which degree of dissociation depends? Right? Alpha depends upon A, naturally, nature of electrolyte. Naturally, we are discussing electrolytes because remember, ionic equilibrium is the chapter made for patients, made for weak electrolytes. Nature of electrolyte. Nice. What is the meaning of that? Acetic acid is having different value. Formic acid is having different value, right? Like this. So whenever we are discussing nature, change the acid, change the base. No, no, sir. I keep nature same, but I am changing the nature of solvent. Usually we take water, but it is not necessary. Therefore, if you take solvent other than water, polar solvent, then what happens? It depends upon nature of solvent. Sir, how does it depend upon nature of solvent? It depends upon ionizing power of solvent. Who is going to define ionizing power? Dielectric constant. Therefore, as yesterday we have said, as dielectric constant, please don't get confused with K. There are so many K are coming here in this case. Dielectric constant K, as dielectric constant K increases, remember that degree of dissociation also increases because dielectric constant is power of solvent to break up that one. In your notes, write down dielectric constant. Right. Next. No, no, sir, I am not changing nature of electrolyte. I am not changing the solvent, but I am changing the temperature. Okay, no problem. Temperature. What happens here? As you increase the temperature, thermal agitation increases. They will have fast movement. And as thermal agitation increases, ionization also increases. As temperature increases, degree of dissociation also increases. Right? Next. No, sir, I am talking about dilution. Okay, Ostwald dilution law. Just now we have studied. What we have studied, alpha is directly proportional to, make a difference between alpha and directly proportional to volume, right? That means alpha 1 by alpha 2 is equal to under root V1 by V2. Next. Apart from this, now a beautiful question is coming to you. Be alert, right? That the concept which I am discussing now is itself a 4 marks question, and it is main students. It is applicable in problems to solve. What is that? See here. Suppose, for example, you are saying that I am having the HA. चलिए acetic acid की बात करेंगे. CH3COOH. Right. Now I am not taking water into account. You are a genius. You can understand what is the way of understanding and explanation. CH3CO minus and H plus. Okay. Along with water, all this takes place. What is the situation? C, right? 0, 0. C into 1 minus alpha, C alpha, C alpha. Right? Then K. Remember that this is the story of ionization of acetic acid when you have added acetic acid in water. Thoda sa dhyan se suniye. When you are adding acetic acid in water. Finished. One boy has taken, first of all, HCl in a container along with water, and then he is taking acetic acid. Two substances are available. Then what happens? Be careful and listen. Okay. Suppose, for example, if I am having HCl here, what happens? Irreversibility. Why? Sir, strong electrolyte. It gives you H plus and gives you Cl minus. Let us say the concentration is C1, right? 0, 0. And at the end state, what happens? This becomes 0. Right? You people are genius. You can understand, right? There is no need to write two lines. This is 0, and then it happens to be something like this, sir. It is 0, and whole of this has been converted. Whole of this is converted. Therefore, when you are saying that, sir, we are having strong electrolyte, this is 0. Not necessary to write down. This is C, and this is C. No alpha. No alpha. Is it clear? C 0, 0. C becomes 0. This is C and C becomes 1. Now, if suppose you are having HCl, in presence of HCl, you are studying dissociation, ionization of acetic acid. Then what happens? Now see the change which I am making. What happens here? Suppose, for example, you are saying, sir, this is C alpha. Keep that in mind, what we have written here. C0, 0, right? Now, C0 is not correct, sir. Already we are having dash. What? H plus ions available. What is that called? C1. What is C1? Concentration of strong electrolyte. Now I will make it as C2. C2, 0, C1. This is the story at time t is equal to 0. Now time t is equal to t. What happens? C2 into 1 minus alpha. Normal behavior. Then this is C2 alpha. No, sir. C1 plus C2 alpha. Yes. This is the resultant concentration of H plus ion in the container. Here also we write C1 plus C2 alpha. This is called simultaneous equilibrium. Yes, two substances are available. Both of them are giving you same type of species. Therefore, I cannot say the H plus ion coming from HCl is red in color. The H plus ion coming from acetic acid is blue in color. No. Therefore, we should say combined strength of these two fellows as common effect is taken. If suppose, for example, you are having electrolytes in such a way that you are having some ion, take care of my language. If they are having some ion which is supposed to be common to them, then what happens? Now, call to Mr. Le Chatelier. What Le Chatelier says, whenever you are having equilibrium, if concentration of products increases, reaction goes to backward direction. Reaction goes to backward direction. And if reaction is going in backward direction, what happens? alpha value decreases. Alpha value decreases. That means this is not alpha. Remember, this was alpha when you are having pure acetic acid. Now it is degree of ionization in presence of HCl, and you are saying that according to Le-Chatelier principle, if you increase the concentration of products, equilibrium goes to backward direction. Equilibrium goes to backward direction. It means now we have to say equilibrium like this, that sir, this is supposed to be longer line and this is supposed to be shorter line. And once you are saying equilibrium is shifting to left hand side direction, it will be something like this. This alpha is now called alpha dash. Again, I am repeating the sentence. Alpha was degree of dissociation of acetic acid in the absence of HCl. In the presence of HCl, since it is a strong electrolyte, we have a large number of H plus ions available. Therefore, overall H plus ion concentration increases. Hence, backward reaction is favored because of this. What is the meaning of backward reaction? Dissociation is decreased. Therefore, new value of alpha is alpha dash. And what is alpha dash? Alpha dash is very much less than alpha. And it is so because of one effect. What is that effect? That effect is known as common ion effect. This is called as common ion effect. Hence, degree of dissociation also depends upon a property called common ion effect. Okay. Now, once you are saying this, what is the analysis of this whole discussion? See here carefully. In presence of strong electrolytes, please write down full form when you are writing the notes. Degree of dissociation of weak electrolyte is, see the word, further suppressed. Already it is weak. Already it is weak, but again you are saying, sir, it becomes further weak, further suppressed, right? This is called common ion effect. Okay, that means alpha value depends upon degree of dissociation, depends upon common ion effect. And what is the significance of common ion effect? Remember, the word common ion effect is to be used whenever you are having basically first thing, strong electrolyte should be present. In presence of strong electrolyte, the behavior of weak electrolyte is discussed as common ion effect. Therefore, degree of dissociation depends upon all these factors along with one more factor known as common ion effect. Right? 1, 2, 3, and 4. Last week, 5 factors. There is one more thing. Once your maturity increases, I'll tell you that also. Take down now. Any question to ask? Is it over? Fine. That will stop here. Now the question is, sir, you are saying degree of dissociation is further suppressed. What is its influence? how does it change the scenario of the system? Yes, that will enjoy that point in the next class tomorrow. Thank you. Assalamu alaikum.
बच्चे लोग आरडी बच्चे लोग आरडी
लेफ्ट वाई
एक काम करेंगे लेफ्ट वाई इज इक्वल टू एफ ऑफ एक्स
बी ए रियल वैल्यू function
रियल वैल्यू फंक्शन
on a comma b closed
defined on closed a comma b such that
there is f of x is continuous on
closed a comma b
f is differentiable on a comma b. F of a equal to f of b.
f of a equal to f of b RT says there exists C belonging to open a comma b such that f dash of
equal to 0. Yes.
what do LMVD says?
There exists
C belonging to open a comma b such that
f of
P is equal to
F of B minus F of A by B minus.
by B minus A.
Sir.
And Cauchy mean value theorem says
Let Y equal to F of X.
by G dash of C is equal to F of
B minus F
of B
by
minus
G
F
of
of
B
A by
minus G of A.
G of B minus G of A. Am I correct?
Yes, sir.
Finished, man?
Yes, sir.
Can I Can I clear this off?
Yes, sir.
Inequality. Look here.
Yes, sir.
What is the function to be chosen by looking at the problem? Choose. बोलो man.
Of x equal to log x.
X belongs to closed A to B. Come on. Apply LMBD.
Yes, sir.
Apply LMBD. I'm waiting. Apply LMBD. I'm waiting.
Yes.
Can I?
Yes, sir. Yes.
One by AB.
Can I?
Yes, sir. Yes.
What do you add? F dash of C LMBD.
So,
1 by x.
f of b minus f of a by b minus a.
But chalo, what is F dash of X?
1 by x.
No, 1 by x. Yes, sir. 1 by
F dash of C.
1 by c.
1 by C is equal to F of B minus F of A.
Log of b by a.
Log of b minus log a.
Denominator.
b minus a.
B minus a.
So what is log B minus log A man?
Log of b by a.
Wait man. What is log B minus log A? B minus A by C.
Yes, sir.
Log of B by A.
b minus a by c.
Since A less than C less than B, I have 1 by C. From this, what is 1 by C? Or log of B by A by B minus A is equal to what man?
c 1 by c. 1 by c. Yes.
Since A less than C less than B, take reciprocals क्या आएगा?
1 by b
1
less
by
than
b
1 by c less than 1 by a.
What
Yes.
is 1 by right in the reverse order? 1 by B less than 1 by C less than 1 by A. बच्चे लोग हमारे
Yes, sir. Correct, sir.
what is 1 by B? Or what is 1 by C?
Log b by a minus b minus a. Sorry, by b minus a.
Cross multiply B minus A. B minus A is positive. Cross multiply B minus A, divide. Give me the answer.
Yes, sir. What's it?
Done, sir.
बच्चे लोग आंसर आया?
Yes, sir.
B minus A by B less than log B by A less than B minus A by A. Correct?
Yes, sir.
1 minus A by B less than log of B by A less than B by A minus 1. Correct?
Yes, sir.
That's what you have to prove. So tomorrow Friday, log in sharp at 10:45. I leave you
Yes,
sharp
sir.
at 10:45.
Yes, sir. We will log in, sir.
For x equal to 0, which is obviously true. Am I correct?
Yes, sir.
Hence, for x greater than 0, it is proportional. What? X by 1 plus x less than log. For x equal to 0, which is obviously true. Am I correct?
Yes, sir.
Hence, For x greater than 0, it is what x by 1 plus x less than log 1 plus x less than. Am I correct?
Yes, sir. Yes, sir.
So what I should consider? Bolo man. F of x equals to
Log
log
1
of
plus x.
1 plus 0 less than c less than x.
Yes, sir.
That is c belongs to 0 to x. Come on,
0, comma x. Yes.
come on, apply LMVD. Apply LMVD, chalo. Shall I?
Yes. Sir, going to finish, sir.
What is f dash of x? Or f dash of c?
Sir, 1 by 1 plus c.
F dash of c.
Sir, got, sir. Got the answer, sir.
F dash of c log
1 by
f of c f of x.
is f of x minus f of 0 by x minus 0.
Bachalo, what is f dash of c?
F dash of c 1 by 1 plus x is 1 by 1 plus c, sir.
Am I correct?
Correct, sir.
Am I correct?
Yes, sir. Yes.
No. What is 1 by 1 or what is 1 plus c?
1 plus c is log 1 plus x by x.
No.
So 1 plus, yes. Sorry.
Since add 1, what does it gives you?
1 less than 1 plus c less than 1 plus x.
1 less than 1 plus c.
Less than 1 plus x.
What is 1 plus c?
X by log 1 plus x.
बच्चे लोग take reciprocals. क्या आएगा?
Yes. So 1 by 1 plus x less than log of 1 plus x. Log of 1 plus x by x less than
You are telling all
Yes.
wrong.
Yes, sir.
That's all wrong. Right? 1 greater than reciprocal greater than 1 by 1 plus x. Am I correct, man?
Yes, sir.
Multiply by x. Yasin bhai, you are telling all wrong. Greater than x by 1 plus x. Correct, man?
Yes.
Yes.
Order. X by 1 plus x less than. Correct, man?
Yes, sir.
Yeah, that is what you are asked to prove.
Completed, sir.
Matrix matching. बच्चों लोग आंसर one of the best problems. This is based on two things.
Rolls theorem.
If f of x has n
N,
root,
f dash of x has n minus 1 roots.
f dash of x has how many roots, man?
N minus 1 roots. Minimum. Yes, sir.
Non-Jacint respond, am I correct?
Yes, sir.
Next, और एक चीज, if क्या करूं जी मैं, f का डिग्री n है,
Yes, sir.
g का डिग्री m है,
Yes, sir.
then अब
Nm. So, sir, n plus n.
hello, x square plus 2x plus 3 f of x, g of x is equal to x cube plus 7x plus 8. What is f of x into g of x, man? Is it mn or m plus n or m minus n or m by n?
M into n, sir.
Non-Jacint
M plus n.
what's the degree, man?
5.
माने fg का डिग्री क्या होगा?
M plus.
समझ गए?
Yes, sir. So,
Yes, sir.
Yes, sir.
आंसर बोलो, बहुत हो गया.
yes, sir.
समझ गए?
Nm. So, sir, n plus n.
Hello, x square plus 2x plus 3 f of x, g of x is equal to x cube plus 7x plus 8. What is f of x into g of x, man? Is it mn or m plus n or m minus n or m by n?
M into n, sir.
Non-Jacint
M plus n.
what's the degree, man?
5.
माने fg का डिग्री क्या होगा?
M plus.
समझ गए?
Yes, sir. So,
Yes, sir.
Yes, sir.
आंसर बोलो, बहुत हो गया.
yes, sir.
Shall I?
Yes, sir.
Yes, sir.
What man? इसका ग्राफ ड्रॉ करो. Mark on the number line. What is f of a?
0.
F of b?
2.
Jasim, please wait. Positive values lie above x-axis. Negative values lie below x-axis. Am I correct?
Yes, sir.
Therefore, b is 2. C is -1. D is 2. E is 0. Correct?
Yes, sir.
How many minimum number of zeros f of x has? 1, 2, 3, 4. Remember? Hello?
Sir, one problem will.
Huh? We have done already. Problem of this type. A is 0. B is 2. Directly I drew like this. Please understand the difference. Directly I drew like this. Can I draw in any other method?
Yes, sir.
Correct?
Yes, sir.
Yes.
C is negative. Correct?
Yes, sir. Yes, sir.
D is positive. Correct?
Yes.
E is 0. Is this graph correct? This is for
Minimum.
Minimum roots.
number of bolo ji.
Roots.
Yeah, roots ka what in place of roots, what is the name he is using?
0.
Zeros.
Zeros, sir.
Now, how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 zeros है. You can keep on और बढ़ा सकते हैं, और बढ़ा सकते हैं, और बढ़ा सकते हैं.
Infinite.
But how many minimum?
4.
Therefore, answer for A.
R.
A matches to R. Come on, बाकी के सॉल्व स्टार्ट करो. You can keep on और बढ़ा सकते हैं, और बढ़ा सकते हैं, और बढ़ा सकते हैं.
Infinite.
But how many minimum?
4.
Therefore, answer for A.
R.
A matches to R. Come on, बाकी के सॉल्व स्टार्ट करो.
Yes.
Sir, B is P. C is S. D is Q.
Can I?
Yes.
अब ये देखो, व्हाट इज योर जी, पहचाने?
Sir, f dash of x 3 roots.
व्हाट इज योर जी? आंसर फॉर सी.
C answer is S. Sir.
व्हाट इज योर जी?
G is 8 3.
और कोई बोलता ही नहीं. होल्ड डैश. What principle you apply in derivative?
Product rule.
UV, product rule. F of x derivative f dash x, f dash x, f dash x, f dash x whole square plus f of x into this function derivatives f double dash x.
Sir.
What is f of x का degree?
4.
N.
Sorry, sir.
बोलो मैम.
N.
4 का minimum
Four.
number of zeros.
So 4 roots.
F dash x का
3. So 4 roots.
whole square plus f of x into this function derivatives f double dash x.
Sir.
What is f of x का degree?
4.
N.
Sorry, sir.
बोलो मैम.
N.
4 का minimum
Four.
number of zeros.
So 4 roots.
F dash x का
3.
3.
so f into f dash का degree
7.
7.
इसका डिग्री 7, उसका डेरिवेटिव का
6.
N minus 1 6.
so answer for B
6.
6 का या 6 सर इस
P
P.
sir P. P.
Answer for D
5. Q.
5. correct.
Yes, sir. Correct.
सेम प्रॉब्लम और एक दूंगा, करेंगे.
Yes, sir. Sorry, sir.
बोलो मैम.
N.
4 का minimum number of zeros.
So 4 roots.
F dash x का
3.
3.
so F into F dash का डिग्री
7.
7.
इसका डिग्री 7, उसका डेरिवेटिव का
6.
N minus 1 6.
so answer for B
6.
6 का या 6 सर इस
P
P.
sir P. P.
Answer for D
5. Q.
5. correct.
Yes, sir. Correct.
सेम प्रॉब्लम और एक दूंगा, करेंगे.
Yes, sir.
बच्चे लोग क्लियर?
Yes, sir.
Yes, sir. Yes.
सेम प्रॉब्लम और एक दूंगा, करेंगे? It takes more time to write the problem than the solution.